Guys, so up until today, we've been looking at different types of triangles, and we've learned a few different things about them that can make it simple to solve for the measures of their sides and their angles. We know that if you add all three interior angles, so the inside angles of any triangle, you're going to get 180 degrees every time. So this helps us actually solve for missing angles. If we have two of the angle measures, we just subtract the two angles you have from 180 to figure out the third measure. Easy. We also know that with equilateral triangles, all three sides are the same, so since their measures are equal to one another, we can actually set any two of the sides equal to each other, so put an equal sign in between them and solve for a variable. We can use a similar method with isosceles triangles that we've looked at, so making sure the two sides that are the same or can be set equal to each other. And having isosceles and equilateral triangles makes solving for sides pretty easy. But today we're going to be looking a little more in depth at isosceles and equilateral triangles and how their angles are related to one another and to their sides. So let's look at isosceles triangles first, and let's look at the different parts of an isosceles triangle. So from the definition, we know that two sides of an isosceles triangle are the same or congruent to one another. Okay, so that's what an isosceles triangle is, a triangle with two sides the same. The two sides that are the same are called the legs of the triangle. And so in this triangle, I'm already on blue, good. To the right here, we can see that the two legs that are the sides that are the same length are AB and BC. So these two, because they're marked with this little tick mark here. So AB, side AB, and BC. Okay, so those are the legs of the triangle. And the angle where these legs intersect each other or they meet each other at the corner is called the vertex angle. Okay, so I'll use this little pretty color here. So this is the angle where these two sides meet. So that's the vertex angle. So this is going to be angle 1 in this triangle. The side that's opposite the vertex angle, okay, the side that's opposite the vertex angle is called the base. So the side that is kind of left over, so the one that's not the same as the other two. So the side that is the base here is side AC. Okay? And then lastly, if we look at the angles that are along the base, so the angles at the end of each leg that they don't share with one another, so if you trace the end of the leg to the angles that they don't share, you're going to get 2 and 3. So angle 2 and angle 3 here are the base angles. Okay, so now that we know the different parts of an isosceles triangle, we have a couple new theorems that we can use to solve for different parts of the triangle. Okay, so the first one, we have the isosceles triangle theorem, and it says that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. Okay, so this says, if I can use easier way to explain it, that if a triangle has two equal sides, so if you have an isosceles triangle, then the base angles are the same. They're congruent to one another. So we have if AB is congruent to BC, so if the two sides are the same, then angle 2 is congruent to angle 3. So they have the same measure. We can do the same thing with A and C, however you want to do it. Okay, so if we have a triangle that's isosceles, so if we just have some random triangle here, some random isosceles triangle here, sorry about that, and we know that these two sides are the same, the two base angles are the same. That's the same for any isosceles triangle. They have the sides the same, then the angles are the same as well. So we can also look the other way. Okay, the converse of the isosceles triangle theorem, and it states that if you have two angles of a triangle that are the same, so if you have a triangle like this and you have the two angles are the same, then you can also say that the two sides are the same. So if angle A is congruent to angle C, then the sides are the same. They're congruent. So if you have two angles and the matching sides would be the same as well. So we can use both of these when actually solving for sides and angles of the triangles. So let's look at some examples, and let's try and apply these theorems to solve for the sides and angles. So number 1, we have triangle JKL, and we have the angle L is 68 degrees. And the two sides JK and KL are congruent, since they have the same number of these little congruency tick marks, so they each have 1, so they're the same. We'll mark these two sides. Okay, I'm going to go ahead and mark them with blue. You don't have to do it, but just to show that these are the legs that are the same. Okay, since we have that those legs are the same, that means that these angles are the same. So J and L are the same. So angle J is also 68 degrees. So I'll mark it there and there. Okay, and then if we need angle K, we just take 180 minus one angle minus the other. Okay, that's going to give us 48 degrees. Okay, so now if we look at number 2, we have a triangle that has two sides marked with congruency tick marks again. It's an isosceles triangle, so we know that the base angles are going to be the same. So C and E are the same. We know that the whole thing is going to add to 180. So we're going to have this 180 is going to be 2 times whatever this angle is that we don't know. So I'll just go ahead and say angle C here. Okay, so 2 times angle C. And then we have this 106. Well, if we solve for angle C, we subtract 106 to the other side, and then we divide by 2. So this angle C is going to be 37. And since we know that angle C is 37 degrees, we know that angle E is the same, because it's isosceles, so the base angles are the same. So they're both 37. Now I want you to try number 3 on your own, okay? Try it completely on your own. It's very similar. You have the angles, so you know that these two sides are going to be the same. Try it your best. Okay, so now let's look at number 4. So these, instead of having just the values, the numbers, we're going to look for variables. So again, we have an isosceles triangle here. So we know that these angles are the same. Since the angles are the same, we can just put an equal sign between them. So you have 5x plus 9, and then 8x minus 30. Okay? We'll subtract the 5x to the other side. 9 equals 3x minus 30. Then we'll add 30 to the other side. Gives us 39 equals 3x. And if we divide by 3, we get 13. Okay, so those two are equal. So you can just put an equal sign in between them. Same with this one, okay? These two angles are going to be the same since the sides are the same. Try that one on your own. Put an equal sign in between them. Do it on your own. Solve for x. Go and pause and do it now. Okay, so at the end of that, you should have got that x is equal to 8. So if you didn't, go back and try again. And we'll go on to number 6. Okay, so we know that these angles are the same, and so the sides that match up with them are also the same. So now we have this 15x plus 7, and it's the same, so it's equal to this 23x minus 17. Okay, so now let's go ahead and subtract the 15x to the other side. So subtract 15x to both sides. 7 equals 8x minus 17. We'll add the 17 to the other side, giving us 24 equals 8x. And if we divide by 8, we're going to get the x is equal to 3. Okay, so same way on this one. Since these two angles are the same, means that these two sides are the same. Put an equal sign in between them, solve for x. Go ahead and pause and do it now. Okay, so I am not going to actually show you what your answer should be on that one. So we're going to go on to the next page. So looking at number 8, we're going to go ahead and read it first, and we're going to try and draw a diagram. So in triangle RST, okay, so we're going to need this information. We know that RT is the same as ST, so these two sides are the same. And then it gives us measure of angle R, measure of angle S, and measure of angle T. Okay, so we have RST. So let's draw my triangle. RST, RT, and ST are the same. Okay, so that means that we have the R and S are the base angles, so they're the same. So we know angle R is equal to angle S. Okay, well, we have the angle R up here is this 9x plus 2, and angle S is this 13x minus 18. So now we just have to solve for x. Okay, I'll subtract the 9x to the other side. Oops. Subtract the 9x to the other side. Okay, that gives us 2 equals 4x minus 18. We'll add 18 to both sides. That will give us 20 equals 4x divided by 4. Gives us the x is equal to 5. So we can go x is equal to 5. Now we just have to figure out what angle is what. So angle R, we already wrote, is 9x plus 2. Instead of x, we need to put a 5. Okay? 9 times 5 plus 2, if you type it in a calculator, you're going to get 47 degrees. So angle R is 47 degrees. And we know that angle R and angle S are the same. So angle S is also going to be 47. And then to find the last angle, you can either do 17 times 5 plus 1, or you can subtract these two from 180. You can also do 180 minus these other two angles. And either way, you're going to end up with an answer of 86 degrees. Okay? So number 9, I'll go ahead and show you how to draw the triangle. I'll set it up for you, rather. So we have DEF. Okay? Angle D is the same as angle E. Okay? So now we have these two sides being the same. So we have DF and FE. Okay? Looks like they did EF. It's the same thing. The order does not matter on these ones. Okay, so I'll do EF. So you're just going to fill in these things. Fill these two here. Just substitute them in here. Okay? And then you're going to solve till you get x equals some number. Then you're going to plug them back into these in order to figure out what the length of each side is. So go ahead and pause and do that. And then after that, go ahead and take your time and try number 10 completely on your own. So go and pause and try that. Okay? So now we're going to move down to equilateral triangles. So these are a little even easier. Sorry. So an equilateral triangle, again, is one with all three sides are the same. So it actually is true that a triangle is equilateral if and only if it's equiangular. So all equilateral triangles are equiangular, and all equiangular triangles are equilateral. So if it has three angles the same, then all three of the sides are the same. Okay, and if all three of the sides are the same, then all three of the angles are the same. Okay? So if you have all three sides the same, then you know all of the angles are the same. And if you have all the angles are the same, then you know all the sides are the same. And if you have an equilateral triangle, actually so there's 180 degrees in a triangle, right? If it's divided into three equal angles, then it's going to be 60 degrees. So all equilateral triangles always have 360-degree angles. Okay, so looking at number 1, we can see that AB is 9 foot, and if we look for C here, we can see that it's going to be 180 minus these two 60s. Gives us 60 degrees. So we can see here that this triangle is equiangular. So we also know that it's equilateral, so all three sides are the same. So angle C is going to be 60 degrees. BC is going to be the same as this one, so it's going to be 9 feet. And AC is also going to be 9 foot. It's going to be the same. Okay, so you can see that on 12, all three of the sides are the same. Go ahead and try this out on your own. Then I'll go ahead and do number 13. Okay, I'll set it up for you to do it. So we know that PQR is equilateral. Okay, so with the sides, you know that you can put any two of the sides in these blanks. It has to be one of the sides. Then you can go down, and that'll solve for y. Okay, so you can do the 14y minus 59 equals 9y plus 1. y plus 1 equals 11y minus 23. As long as you pick two of them, solve for y for like that. And then we also have the angle R is a 7x minus 3. And we know that each of the angles in an equilateral triangle are 60 degrees every time. So with this, we know that this 7x minus 3 is going to be 60. Go ahead and solve for x with that. Okay? So that's it for equilateral and isosceles triangles. So basically, if you know that it's isosceles, the base angles are the same. And if you have the two angles, then the matching sides are the same. For equilateral, you can set an equal sign in between any of the three sides, and each of the angles is always equal to 60 degrees. So let me know if you guys have any questions or any problems with this. I hope you guys have a great day, and make sure you look at the Padlet problems. You're only doing 5 problems this time, I think. Actually, I think it's more. But they're these types of problems. A lot of them are really simple. Just make sure you read the directions correctly and get it done. You guys have a great day and a great week. Bye.